Hello, good evening, everybody. This is our second class for algorithm. Please, if you know that any of your colleagues are not online, please do well because today we'll be studying a very important topic in algorithm. Okay, before we dive into what we have for today, we are going to do a brief recap of what we did last week. Last week, we were able to establish some things. We got to understand what algorithm is. We talked about the characteristics of an algorithm. Then we moved to the types of algorithm. And so far, so good. I've gotten the assignment of which I gave last week. Please, for that assignment, I would want to recommend something. There are some people, they did their own the way I like, and some people they did it haphazardly. Please, any assignment which will be given to you during the course of all your online studies, please take them very serious because they constitute part of your CA. This part of your CA, and at the end of the day, the cumulative is going to be what will determine your grade, will be used for your grading. Please pay attention to them. Then when answering your assignment, first of all, make sure that the subject is titled the course, either you put the course code or you put the course title. The subject should either be the course code or course title, preferably the course title. Then make sure you answer it on a fresh page, then you attach it. Please make sure you do these things. List the question, then you answer it. The answer should be beneath it. Okay, let's go to what we have in today. Just like I said earlier, we established what is algorithm. Then we talked about characteristics of algorithm. Then from today, we'll be going to what is called how to write an algorithm. How to write an algorithm. I hope everybody is seeing my screen. How to write an algorithm. Understand that there is no stipulated way. There is no one way of writing an algorithm. Take note of that. If you will have 10 different programmers and you give them one single problem to bring up the algorithm, understand that for each of these 10 of them will be having different problem solving, but at the end of the day, what is needed is for the answer to be achieved. Take note of this. Okay, there is no well-defined standard for writing algorithm. Rather, it is a problem and resource dependent. It is a problem and resource dependent. Algorithms are never written to support a particular programming code. They are never written to support a particular programming code, in the sense that your algorithm can be implemented, can be written on different programming code, different programming language. Please take note of all this which I am listing. Okay. We have a problem here. We have a problem here, and let's see from what you can see on my screen. Please take note of this. We have a problem here, but for this very problem, it was solved in two different ways. The problem here is design an algorithm to add two numbers and display the result. Design an algorithm to add two numbers and display the result. The step number one is start. Step number two is declare the integers. Declare the three integers. Declaring the three integers. Most of us which have done data structure, we understand what are integers. They are kind of a data structures that has to do with numbers. Refer back to your data structure. You declare them, since you are dealing with numbers, you declare them as integers. If you are dealing with Boolean, you know that you are talking about figures that have points. But now we are dealing with numbers that are single numbers. So you declare them as integers. Declare the three integers A, B, and C. That is for step number 2. Then step number 3, define the value of A and B. Define the value of A and B. Understand that the problem is define an algorithm to add two numbers and display the result. At the end of the day, you are declaring three integers because your two numbers will be added together, then passed along to C. Understand that A, B, and C are called containers. They are called variables in the sense that the number there can differ. They differ. Are called variables, also known as containers. Then you define the, sorry for that, you define the value of A and B. After defining value of A and B, which is for step number 3, then step number 4 is add the value of A and B. Add values of A and B. Step number 4. Then step number 5 is store the output of step number 4 to C. The output which was generated from step number 4, you would store it in C. Then step number 6, print C. Then stop. Step number 7. Understand when we are talking about our characteristics of algorithm, we talk about what was called input and output. So at every iteration, I used that word last week. After every iteration, at the end of every iteration, there should be something that comes next, which will be the stop. That, now, as stated from here, this is the solution to that problem. This is the solution. To that same very problem, we have another solution to it. You don't see on my screen, this one is shorter. You understand that this one is shorter. Step number 1, start and add. Then get variables of A and B. Step number 3, C is a function of A, B. Step number 3, C is a function of A plus B. Step number 4, display C. Step number 5, stop. These are two different answers, which we, at the end of the day, we give you the same output. But you understand now that the step of solution 2 is shorter. Why the solution the first solution is longer. So that is that. One single way of solving or writing an algorithm. But you have to understand that at the end of the day, the desired output must be met. In design and analysis of algorithm, usually, the second method is used to describe an algorithm. It makes it more easy for the analyst to analyze the algorithm, ignoring all unwanted definition. He can observe what operations are doing and being used and how the process is flowing. Professionally, solution number 2 is ideal because it cuts every unnecessary steps are being removed. So understand that peradventure later in the future, when you begin to design your own algorithm, you understand that you will get to understand that there are unnecessary things which you need to forfeit when writing your algorithm. There are things, unnecessary things which you understand that okay, it is not needed. Mainly looking at these two of them, you understand that the solution number 2 is well structured and it is presentable. Very importantly, it is professionally written. It is professionally written. Okay. We'll be going to algorithm analysis. Please take note of this. Algorithm analysis. This is to some very extent, this is where so many people miss it in implementation of an algorithm. I will go back. When we were discussing about the characteristics of an algorithm, there was one of the characteristics which was mentioned, which is called visibility. Visibility is talking about your algorithm which is to be implemented should be able to be visible, should be compatible with the available resources. It should be available with the available resources which will be implemented. Algorithm analysis is where algorithm analysis is being taken out from. Please take note of this. Efficiency of an algorithm can be analyzed at 2 different stages: before implementation and after implementation. Take note of this. The efficiency of the algorithm can be analyzed at 2 different stages: before implementation and after implementation. Why is it so? Analysis. This is a theoretical analysis of an algorithm. It is theoretical analysis of an algorithm. What does this state? The efficiency of an algorithm is measured by assuming that all other factors, what are these factors which are being considered? Number 1, your processor speed. It is being assumed for your theoretical analysis. It is being assumed that your processor speed are constant and have no effect on the implementation. That is what your preparer analysis is saying. Then the second one is called your post-processor analysis. In post-processor analysis, this is an empirical analysis of an algorithm. It is an empirical analysis of algorithm. This states that the selected algorithm is implemented using programming language. This is then executed on the target computer machine. In this analysis, actual statistics, running time and space required are collected. This is actually where the main thing comes in, because in your first analysis, which is called your preparer analysis, it is assumed that your processor speed, this is just an assumption. It is just an assumption. Understand that all things can't be equal at every point in time. it can be equal at every point in time. There are unforeseen circumstances. But for your post-moral analysis, it that it is at the implementation method that is where the starting everything is being collected. The statistics which are being collected now is number one, we are talking about your time which it takes your algorithm to run. Then secondly, the space algorithm. These are two of them: time and space. Okay. Just like it is written. Algorithm analysis deals with, now this is what algorithm analysis is actually stating. Algorithm analysis deals with the execution or runtime. Algorithm analysis deals with the execution or the running time of various operations involved. Algorithm analysis deals with the execution or the running time of various operations involved. The running time of an operation can be defined as the number of computer instructions executed per instruction, per operation, sorry. The running time of an operation can be defined as the number of computer instructions executed per operation. Please take note of this. Then we are going to go to algorithm complexity. Algorithm complexity. Algorithm complexity is throwing more light into your time factor and your space factor. Your time factor and your space factor. Your time factor and your space factor, which was mentioned in your preforal analysis. The complexity of an algorithm is a function of f of n. It's a function of f. It's a function of f of n, which measures the time and the space used by an algorithm in terms of input size n. Understanding that there are two things which are governing your algorithm. When implementing or when writing an algorithm, as a computer scientist, take note of number one, your time. Time is telling you that with the current hardware, with the current system which you are having, okay, understand that you can't actually achieve both of them at the same time. Understand this. If you want your algorithm to be more faster, then you understand that the size of the algorithm will be little. Then if you want your algorithm, if you want it to be of a larger size, then understand that the time factor which it will take it for it to compute instruction, the time which will take it to compute instruction per operation will be longer. Take note of these two things. Okay. The complexity of an algorithm is a function of f of n, which measures the time and space used by an algorithm in terms of input size n. In computer science, the complexity of an algorithm is the way to classify how efficient an algorithm is compared to alternative ones. Compared alternative ones. Okay. Suppose it's an algorithm. Your X is an X is the size of the input data used by the two main factors which describe the efficiency of your X, which is the algorithm. So the efficiency of your algorithm is determined by time and space. The efficiency of your algorithm is being determined by time and space. Please take note of this. So as a computer scientist, you have this at the back of your mind. Whatever you are working with, whatever algorithm you want to implement, you will have to work in accordance with the visibility of the hardware which you are having. Please take note of this. Okay. What is the time factor? The time factor. Time is measured by counting the number of key operations, such as compression in certain algorithm. That is time factor. How many operations will it carry every running? How many instructions will be carried out per operation? That is what time factor is telling you. How many instructions will be carried out per operation? That is why it said time is measured by counting the number of key operation. Key operation. That is per instruction, every instruction that will be carried out in the operation. It is being governed by time. Then the second one here is the space factor. The space factor is measured by counting the maximum memory space required by the algorithm. Your memory space is your hardware. Your hardware, the memory space. Talking about your hardware. So the space is measured by counting the maximum number space required by the algorithm. Understand that the reason for this is for you to understand that there is something called buffer. Your buffer is considered to be a temporary container where instructions are being stored or where instructions are being run. So if your buffer, the size of your buffer can't contain the instruction which an operation is to be carried out, understand there is something called buffer overflow. Buffer overflow occurs whereby the segment implemented for instruction for operation to run is overwritten and goes to the other way, the other side of the memory. Thereby, if that happens, every other operation or every other instruction on the other side of the memory is being corrupted. These are the reasons for this. The complexity of an algorithm, which is f of n, gives you the running time and or the storage space required by the algorithm in terms of n as the size of the inputs. Space complexity. Space complexity. Space complexity of an algorithm represents the amount of memory space required by the algorithm in its life setting. Space complexity of an algorithm represents the amount of memory space required by the algorithm in its life cycle. The entire life cycle of an algorithm. Space complexity is telling you that the amount of memory required by this algorithm throughout the life cycle of this algorithm. Because the truth to be told, so many of the algorithms which we have today, they have been written so many years ago. And most of the times when you have new implementations, what is actually being done is that we already have them in modules. So what is being done that all the modules the modules for each of these algorithms. Take for instance, your source algorithm is a module on its own. Your delete algorithm is a module on its own. Your update algorithm is a module on its own. And insert algorithm is a module on its own. So each of these modules are being collected because it has already been written. There is no need of going back to start from the scratch, except in a situation whereby you feel that this particular module, more can be done, that there is a way I can do it and it will run faster, it will be more efficient than what it is already, than what we already have. Please take note of all these things. So your space complexity of an algorithm represents the amount of memory space required by the algorithm in its life cycle. The space required by an algorithm is equal to the sum of the following two components. The space required by an algorithm is equal to the sum of the following two components. What are these components? A fixed part that is a space required to store certain data and variables that are independent of the size of the problem. For example, simple variables and constant used program size. Simple variables and constant used program size. You are actually being required in a situation whereby a constant that you are using a simple variable, that this variable is something that is not complex. Understand that the constant use of the program size can actually be determined. The actual size of which this algorithm will occupy can be easily determined, because at the end of the day, you already know that this is actually what we are actually running is a simple variable, and understand that you can actually determine this since you are using a simple variable or a fixed variable, that no matter what, at the end of the day, you are all using the same variable, a fixed variable, regardless of the problem which will be solved. So at every point in time, regardless of the problem that will be solved, understand that this same variable will be used and will be reused. So from there you can actually deduce and determine that, okay, this also portion of space can be allocated for it. Social portion of space can be allocated for it. Okay. Then the second one, a variable part is a space required by variables. This is what it's saying. Whose size depends on the size of the problem. Here you are actually dealing with what is dynamic, a kind of a dynamic problem. So understand that the first part is telling you, in a situation whereby you have a fixed kind of problem, understand that you use a fixed amount of memory space. In a situation whereby you are having a dynamic kind of problem that it can't be determined, that there are bound to be changes. There are bound to be changes. Understand that the memory space which will be allocated when implementing your algorithm, you implement it in such a way that the algorithm has the power to apportion space for it at every operation, because the kind of problem that is being solved at each interval after each operation varies. This is what you have to understand. A fixed problem requires a fixed kind of memory space. Then a dynamic kind of problem determines a dynamic kind of memory space. That is for that. Then time complexity. Time complexity. Time complexity of an algorithm represents the amount of required time. The amount of required time by the algorithm to run to completion. Time complexity of an algorithm represents the amount of time required by the algorithm to run completion. Time required can be defined as a numeric function of T of n. T of n, where T of n can be measured as the number of steps, provided that each step consume constant time. Provided that each steps consume constant time. As a computer scientist, understand one thing. When implementing an algorithm, understand that it's either you want your time, that is the running time of your algorithm, if you want it to be faster, then understand that the size of your algorithm have to be small. Understand that the size of your algorithm has to be small. That is why, as a computer scientist, try as much as possible when implementing an algorithm, try to remove irrelevant descriptions. It is very, very important. Irrelevant descriptions, irrelevant definitions when implementing an algorithm. These are part of the factors that slows down an algorithm. Part of the factors which slows down an algorithm. Okay, this is time for questions and answer. Time for questions and answer. Please, time for questions and answer. Our class will be coming, will be ending in the next 5 minutes. Okay, since there are no questions, Since there are no questions, let me say something before I give an assignment. Try to understand this time complexity and space complexity as a computer science student, because time will come that you will have to implement some of these things. Please take note of this. And due to the nature of this class, please, in case you are not clear, in case there are things which you need for me to explain more, please do get across to me. So the assignment for today is, write an algorithm that will sum, all the even number. Write an algorithm that will sum all the even number between 1 to 50. Write an algorithm that will sum all the even numbers between 1 to 50. Divide the result by the mean range. By the mean range. Then display the result. Write an algorithm that will sum this. Write an algorithm that will sum all the even number between 1 to 50, divide the mean range, divide the result by the mean range, then display the result. Understand that in this situation, you are permitted to do almost 4 or 5 things. The first thing is you are writing the sum. You are to carry out an operation. The operations which are to be carried out is operation sum, which is addition. What are you summing? You are summing all the even numbers between 1 to 50. 1 to 50. That is operation number 2. Then operation number 3, you are dividing the result by the mean range. You are dividing the result by the mean range, operation number 3. Then operation number 4, which is to display your result. These are the 4 things which are needed, which are to be carried out. Understand, this is the simplest way. There are people that will go ahead and start giving unnecessary operations, which is declaring the variables. There is no need for you to declare the variables. If you are declaring the variable, understand that you'll be declaring a lot of variables, because you'll be declaring from 1 to 50. There is no need for that. I've given you a heads up on how to go. First operation is for you to sum. Second operation is for you to divide, display the result, and the range. These are the 4 things which are needed. Please, the email still remains sharonchris29@gmail.com. sharonchris29@gmail.com. Please, you can get across to me for more clarity on 08133121309. 08133121309. Thank you for your time, and I hope you enjoyed the class. Have a lovely good evening.